The reason why we need to talk about Mapreduce Job in the context of performance tuning is for the reason you might have looked into the ecosystem diagram what I shared with you some time back. At the very lowest we have storage, and on the top we have processing, and on the top we have access, and on the top we have management, and on the top we have analytics, all in the context of data only. I mean data storage, data processing, data access, data management, and data analytics. At the storage level, we have HDFS, we have HBase, we have S3, NFS with MAPR. So we have like this. So this we have already discussed, HDFS. On the top, we have something called Mapreduce. And on the top, we have something called Pig, Hive, Scoop, all these things. And on the top, we have something called Uzi, Zookeeper, all those things. And on the top, we have a number of tools as part of analytics. So analytics, we don't bother here. That is not our subject. So you develop a pig script and run that. It will run as a Mapreduce job to process the data present on HDFS. You write a Hive query and run that. It will be converted as a Mapreduce job and work against the data present on HDFS. You run a scoop command, it will get converted as a Mapreduce job and run against the data present on HDFS. So even you write a Uzi job, it will work as a series of Mapreduce jobs in the background which runs against the data present on HDFS. So all the other components which you are seeing as part of the Hadoop ecosystem, they are just nothing but a higher level of abstraction on the top of Mapreduce. I hope you understand what I mean by that statement. Higher level of abstraction on the top of Mapreduce. Higher level of abstraction on the top of Mapreduce. So they are Mapreduce only. Even Pig is a Mapreduce, Hive is a Mapreduce, Scoop is a Mapreduce, Uzi is a Mapreduce. But they are not directly Mapreduce, they are indirectly Mapreduce jobs. That is where we call Pig as scripting kind of abstraction on the top of Mapreduce. Hive is a SQL level of abstraction on the top of Mapreduce. Scoop is a layer on the top of Mapreduce to perform import exports against a traditional RDBMS. So all these tools, whatever you are seeing here, all are the different levels of abstraction on the top of Mapreduce. Now, if Mapreduce is being fine-tuned, your data processing is definitely been addressed properly. So that is going to impact your pig, hive, scoop, oozy, everything, right? If MapReduce is being understood properly and if it is being taken care properly, you're mostly done. You're getting the point what I'm sharing here?
Yes.
That is the reason why we need to talk about MapReduce job and its life cycle. Once we understand MapReduce job and understand its life cycle, we get the chance. We get the chance to tune it. Or we understand how the MapReduce job is getting executed. Based on that, we get the chance to tune it. When you tune it, the performance increases. That is how you can make your Hadoop cluster to perform better by fine-tuning your MapReduce job. Make sense, Vladan? You remember the diagram, Vladan, what I shared with you in the beginning?
Yes. Last time.
This diagram, which one? The Hadoop ecosystem. Storage you
Oh yeah.
have, processing you have, access, management, and on the top you have analytics, right?
Yes.
So you look closely there. If you look closely into that, you remember this diagram?
Yes, I remember.
So if you look closely into this one, you can understand your hive, pig, avro, mahout, scoop are different levels of abstraction on the top of MapReduce. Even your Uzi, Flume, Zookeeper, not other things, not other things. They are monitoring tools, so you don't have those things there. So even those are going to depend on this MapReduce indirectly. When you design a workflow using Uzi and try to schedule it or run it, then it triggers the MapReduce jobs only in the background, right? So that is the reason why we need to fine tune your MapReduce job so that the performance of processing the data in the cluster will be elevated. So what do you have as part of the MapReduce job now? What are the let us see how you run a MapReduce job. How you run a MapReduce job, we see. At the terminal, that is what I am showing you here. At the terminal, we say Hadoop zar, Hadoop zar, then we are going to specify where that zar file is located. Path of zar. This is on local file system. Okay. In this zar file, there could be number of jobs. Which job you want to run? So this job name. Are you getting my point, Laden, here?
Yes.
Like how you are saying Hadoop FS, Hadoop FS, and you are giving other commands, right? ls, cp, copy from local, move to local. So all those commands you have. Same like Hadoop zar, and you should specify the path of the zar file, and you should also tell what is the job name, what is the job name. If at all, if your zar has got more than one job, if your zar has got more than one job, then only we should give the job name. Suppose if this zar file has got only one job and that itself is the main class, then we need not specify this job name. Of course, that's all the development aspect. Forget it if you don't understand. If you remember the command to run the Mapreduce job, that is sufficient. So here this job name comes into picture if this jar file has got multiple jobs. Then when the job is running, we should tell from where it should fetch the data. I mean, that is called input. That is called input path. This is the path on HDFS. From where it should read the data to process. And when it is processing the data, it should produce output. Where we should keep the output, that is where we call output path. Output path. Again, this is also on HDFS. So these two needs to be provided. These two needs to be provided by the person who is going to run the job. So we need to be careful in identifying what is the input path. The right input path needs to be given, and the right output path needs to be given. Otherwise, the output will not be stored there. So input path must exist. If the input path does not exist, then if not, exception is thrown during execution. Is thrown. What exception is thrown? Input path does not exist. Well, if the input path does not exist, what it needs to process? That is why if the input path does not exist, then an exception is being thrown. That is why this input path must exist. The input path must exist. Now, same like the output path. Output path. This must not exist. Why? Because you are trying to store the output. If you try to store the output in the existing path, then the existing outcome of some other job in the past might be overridden by this new job. So that is why it must not exist. Suppose if that output path exists, then again it is going to throw the exception saying the output path exists. You got the point, Laden, what I'm sharing here?
Yes.
All these are technically implemented, not just blindly do like this. No. Hadoop zar. When I am saying zar, you should give zar file. That is why you should give the path of the zar file. When you are giving the zar file, if that zar file contains multiple jobs, which job you want to run, that you should tell. That is why job name. When the job is running, it should process your data. Where to find the data, you should give input path. When the processing is done, output comes. Where that output needs to be stored, output path. So this statement is very technically connected. There is no hard-coded thing here. Everything is technically relevant. You agree with me?
Yes.
Have a look at this statement once. Hadoop zar. So I give you an example now. That is what the logical aspect I mentioned. Then now I say Hadoop zar Hadoop ZAR, I specify probably slash home slash Srini slash work slash myjobs.zar. This is a path where I have maintained my. This is a path
This
where
part.
I'm maintaining my ZAR file.
Jar.
Yeah, my ZAR file. Yes, and the job name is my job. Okay, the job name is my job, and I need to specify slash tmp slash tmp slash mary dot txt slash tmp slash mary underscore out. Now you see, this Hadoop jar is common. Hadoop jar is common, and this whatever I'm showing you here, this entire thing is what the jar file path, and this is whatever I'm showing here, job name, and this is my input path, and this is my output path. This output path is nothing but the directory. It is not a file, it is a directory. With that name, a directory is going to be created. With that name, the directory is going to be created. In that directory, the entire output is going to be stored. Have a look at this entire statement and try to retain it by looking into the technicality. So you need not even by heart this. Hadoop jar and the path of the jar file, the job name, the input path, and the output path. All these are technically connected. Make sense?
Yes.
Now, I'm going to run a Mapreduce job now, processing some data so that you will be able to understand how a Mapreduce job is going to run in the background. Yeah. Are you able to hear me now?
Yes. Can you hear me?
Yeah, I'm able to hear you. Yeah.
So okay, how this myjobs.jar gets created in your home
No.
home/Srini
So
slash work directory?
as a developer, you understand what is the task being given to you, understand the data set, and then start developing a job using Eclipse kind of IDE. Okay. And using the Eclipse IDE only, you produce a jar file in the path you want.
Got it. So
Okay.
practically, you write the jobs in Java code, right? Java
Exactly.
language.
Exactly. That is where we are going to make use of the Eclipse IDE.
Okay. Thank you.
I'll show you the job also. I'll show you the job also, how you define the job. That part also I'll show you. Yeah, 1 minute. ఇది అయిపోయింది తల్లి. Let me know. Yeah. So when you run a MapReduce job with all these things, whatever I'm showing you now, so let me take you over there. Now you see this one, Laden, you understand. This is the file browser. I logged in as admin, so that is why I directly came over to this path, that is user/admin. So under user, for every user we have an account. For every account that I create, like how in Linux when you create an account, user account, under home/home, you'll get a directory with that account what you have created, right?
Yes.
So same like even here. So for everything, you'll be able to see accounts. I think you noticed here. All these are the, I think you noticed here. You have Kiran, you have Prasad, Raju, Rakesh, Ram, and you also see an account with my name, Srini. Okay.
Yes.
So inside this, I keep my own directories. Okay. And I have,
Okay.
yeah, so where I plan my own aspects, right? So I think you got the understanding. It is the same like your Linux file system.
Yeah, you have user and you have group that you belong and permissions and everything.
Everything same.
Yeah. Yeah. Okay.
And the only thing is, your traditional Linux system is confined only to one operating system, one machine, and probably one storage. One storage I am saying, that is attached to that computer, that's it. But when it comes to the cluster, we have huge storage accumulated with a number of machines, right? So all those individual hard drives from across multiple machines, still we put together the entire thing as one unit only. That entire thing is one unit only. You got the point?
Yes.
Though, I mean, if you go to the minute level and see, there are number of machines in the background, there are storages, but all that is put together one storage only, right? not multiple. So same is the thing. Same is the thing. So when you look at this one, you understand. Now I open my terminal. Um, so here I'll be saying c/home/ yeah. So have a look at this one, Vladan. Hadoop ZAR. So it is saying, we need to supply the ZAR file. Without you supplying the ZAR file, you will not be able to run that, right? So Hadoop ZAR, I'm specifying word count demo.zar. Okay, word count, then /tmp/ I would like to go here and check where my data set is present. /tmp/ sandbox. There is a file called Mary. I think you noticed here. There is a file called Mary, and in that Mary, so there are words. There are words. I mean, there are sentences, sorry. Inside your Mary file, you have text, some text in the form of words. Okay. This I will provide as an input to my Mapreduce job. Don't think that, a small file, why we need to process only using Mapreduce. We can write plain, normal, simple Java code or some Python code and process this one and find out the output needed. No. The reason why we are using this small file is to get the confidence that when the Mapreduce job runs and takes some input and what output it produces, if you can see all these things with the naked eye, then you will be confident, oh, fine. So this is how the things are happening. You will come to know all those things. That is the reason why we are taking a small file. You apply the same job on any big file, let it be 1 TB or 100 TB or 1000 TB file, you get the expected outcome. But when you develop a job, you are always going to test the job against a small data or sampled data set from the original data set. So there is a team that works which constantly produces sampled data, because producing sample data is also an important thing. Why we require sampled data? Because if the sampled data is not appropriate, when I test against that sample data, I may not be able to predict whether my job is going to run properly or not. That is why sample data should be produced from the original data set in such a way, if the results coming out of the sample data are perfect, then the same results should come even from the bigger data set. That way we need to produce the sample data. Okay, that's all a different story, but I'm just trying to make you to understand. So inside TMP, we have a sandbox, and inside that we have a file called Mary, and I am giving /tmp /Mary underscore out2 or whatever, because already Mary underscore out directory already exists here. So Mary underscore out directory already exists here. If you give the same path, then it is going to throw an exception saying, what did he say? What did he say? What did he say?
Oh,
Vlad?
you couldn't hear me. It says that already exists exception. It gives us
Yeah,
exception that already exists.
because the output directory, whatever I'm showing, that already exists, right?
Yeah.
So that is the reason why it is telling you like that. So what needs to be given now here? Underscore out to some other directory name. If you give /tmp, oh, so this one I don't think we need to give the job name, because this has got directly that stuff. So what is the problem here? Privileged action exception. Oh, sudo su sci. Hadoop jar word count demo.jar stmp /sandbox /mary /tmp /mary underscore out2. You see, Vlad, here the Mapreduce job is running, and what is the issue? That's fine. /tmp /sandbox failed with the state due to the setup fail. No, that's cool. That's not an issue.
You have no permission.
Exactly. I mean, that's where. So you can get the clear understanding from this one.
Yes.
Yeah, that's cool. /home slash. Let
You
me.
probably don't have permission to execute the job.
Exactly. You are absolutely right. You are absolutely right. So we go to the respective path, that is SI, and in that we have a file. We will see Uh, the file is fine. This is the text we have. We'll take this text. Is that fine? Look at this one, Radan. So what is the path? Slash user slash sai slash mapreduce program slash user slash sai slash output x. Oh my god, output x also exists. Output 1, 2, 3. Now have a look at this one, Laden. We finished everything. Now I think you noticed here there is a job that is going to run here. I think you noticed this is for Sai. Okay, there is a job that is running, and you notice that
Yes.
it got just finished. You notice that.
Yep.
So what do you understand from this? You submitted the job to the cluster, and it worked fine. Map phase got executed, so much percentage. Only when map is 100%, only when map is 100%, your reduce starts. So you see reduce going, and finally you got the output something like here, right? And I'll also show you that I take you to the browser. I take you to the browser, and yes, a user, and what is required here? We need to go to the directory by name Sai, and there we need to see for the file called output 123. Output 123. Output 123. That is a path where, yes, these are the files which are being produced. I think you noticed all these are called the parter files where the output is being produced. And you notice here, I'm going to explain you, don't worry for that. But see what's happening. Try to recollect all the stuff and try to coordinate and integrate all that stuff and come to some conclusion. We'll have a discussion on it. A minute, right. Yeah, Aladdin. You have any? See, you have here. There are 20, around 20 reducers that run in the background. That is the reason why you got so many files, because every reducer that runs will produce one output file. If there are only two reducers, then you'll get only two part-tar files. I'll show you some of the directories where, yeah, you see the output directories. If you see the log output, how many part-tar files you got here?
One.
So depending on the number of reducers set by you while running the Mapreduce job, those many part-tar files will be produced. Okay. So now we try to go in detail and see. Yes. So what are the different phases we have as part of the Mapreduce? What are the different phases we have? Are you clear with how you are running the Mapreduce job, Laden? Hadoop ZAR, tell where your ZAR file is located. If that ZAR file has got only one job, then we need not give the job name. If suppose if that ZAR file has multiple jobs, then we should also specify the job name, the input path, and the output path.
Okay. Yeah, I got that.
Right?
And the job is actually a script or a job that you write. I mean, your request, whatever you want that data.
Absolutely. So that is
To be
where you
processed.
as a developer, you are going to get a task. See, this is the
Task,
data
right?
set. This is what the output I want, and this is what the processing that needs to be done. This is a business logic that needs to be implemented. All those details you get from, I mean, certain things as a developer, you do it on your own, but you get all the needed inputs to develop that job, and you are going to develop that job using your Eclipse in Java, and you pack that entire thing into one jar file. Whatever you have developed, that you pack into jar file, and that jar file you submit to the, I mean, packing all those things into jar file is just nothing but right click on the project and say export jar. You'll be able to, you are not going to do anything, you are not going to struggle for that. It's all been done very easily using your Eclipse ID. But the only thing is that being the development front, you may get confused. Oh, what is happening there? I'll try to show you the jar file and the contents inside that one, all that stuff. Don't worry for that.
Okay.
So here if you see the MapReduce part, you are going to understand. See here, See this diagram closely, Vladan. So finally, what is the output? No, watch this one very closely, Vladan. Watch this one
Okay.
very closely. Because you studied mapper takes key and value and produces key and value.
Yes.
Then combiner also takes key value and produces key value. Got the point?
Yes.
If you look at this one very closely, you get everything, Laden. Mapper takes key value, produces key value. Combiner takes key value, produces key value. Partitioner takes key value and it doesn't produces, it only marks which key value should go to which reducer will be decided by the partitioner. That is being done by shuffle. And shuffle is going to physically transport those key value pairs to the reducer. Before those key value pairs are given to the reducer, they are being sorted by the sort phase and finally given to the reducer. Okay, and the reducer is going to perform its operation and finally give the output. Watch this diagram closely for a minute. You will understand a lot. Key is 6 and its value is 1. 6171 6171. Now, how many times 6 is there? 3 times, right?
3 times.
So that is where instead of we transporting 616161 3 times to the reducer directly, combiner will perform local aggregation so that the amount of data getting transferred across the network can be reduced, which automatically increases the performance of the Mapreduce job. You got the point?
Yes.
If suppose combiner is not there in between, Vladan, what the partitioner needs to do? Partitioner should say 616161 should be sent to reducer 1, so that 616161 three pairs need to be transferred across the network. If combiner is there, that 616161 is reduced to 63, so that only one key value pair is being transferred across the network. That increases the performance of your MapReduce job. That is where combiner is called as a local reducer. The actual reducer is a global reducer, but combiner is the local reducer only for that node. Combiner is at the node level, mapper is at the node level, partitioner is at the node level, reducer is at the cluster level, which I have already explained in the past, right? So
Yes.
have a close look at this diagram, very closely at this diagram. We understand a lot of things. Then we'll have a discussion on it. Yeah, learn. So you got the understanding?
Yes.
So you look at this diagram very closely, you understand your mapper. What are the phases we have? Mapper. Then,
Combiner.
very good. Then,
Partitioner.
then,
Shuffle and sort.
then,
And on the end, reducer.
this takes key and value and produces key value. The same will be taken, produces, takes, and produces, takes. And this one, shuffle, actually transports. And sort is going to sort before giving to the reducer. Reducer produces key value. So whatever the input you are giving, similarly you get the same kind of output, same kind of, I'm not saying same output, same kind of output. It takes, your job takes key value and produces key value. That is why I think you noticed here in the output what I am showing you. So you notice here, see this one, this is there 12 times, this text is there 12 times, and this is there 4 times, and this is there 56 times, and this is there 28 times. I think you're noticing.
Yes.
So if you give a log file, if you give a log file to your job, I mean this is a job which is performing the word counting. Okay, not necessary that every time you will be doing word counting. Why we do word counting every time? When you want to do word counting, you will be doing like this. You got the point?
Yes.
So if you look at this one closely, your output is showing what is a word. See, this is a word, right? This entire thing is a word. You know very well what is a word. Word is something between two spaces. In a text file, a word is just nothing but the text between two spaces. That is called a word, right? So how many times that word is repeated in the given text file, that output is coming to you. Now based on this one, I understand in the log file which word is repeated highest, or the top 10 repeated words inside this log file or text file, you'll be able to find out. Thereby you understand which is playing a major role while logging the data. Some analytics can be done on that. That's a different story. But I'm trying to make you to understand what is a Mapreduce job and how your Mapreduce job is going to run, so that if the Mapreduce job is being tuned properly, it is going to impact the overall execution of your entire jobs on the cluster. Thereby, it is going to be efficient. Make sense?
Yes, got it.
So these are all interrelated. These are all interrelated. That is the reason why I was compelled to share or discuss all these things with you. You can see that here. You want, I'll increase its size. Somewhat better now.
Yes, that's good. I see it.
So you see what the map takes as an input. Of course, in between other stages are also there, but to give you the understanding, as I cannot fit everything there, I have shown you like this. So map takes some text. I mean, each map will take one block. Each map will take one block of data. So that block of data is shown there. See, here it is being shown only a line. Don't think that map will take one line. No, map will take one block. You know very well what is the size of the block. The size of the block is going to be around 32 MB or 64 MB or 128 MB.
128, yeah.
Right? So each mapper will take one block of data. Got the point?
Yes.
So hope you understand from this one what is that needed here. So if you look at that one closely, you understand, appreciate what is um, what is the importance of the Mapreduce job and what stages are there and how those stages are contributing. What each stage is doing. You know very well what is mapper doing, what is the combiner doing, what is partitioner doing, what is shuffle and sort, and finally what is reducer doing. Right?
Yes.
So any questions to me on what we discussed till now?
No, so on the previous picture, previous slide that you showed me, it says that the job and then data was divided into chunks. So chunk 1, chunk 2, chunk 3. So
The
this
chunks
practically over here,
are
we
nothing
set
but your blocks only.
one block, right?
Exactly.
Okay.
Exactly. See, your entire data is not getting processed by one mapper. If that is the case, it is
Yeah.
we don't need MapReduce programming. There is a linear programming model.
Yes, I understand it.
So now we go to this one and try to see. See here, every map or reduce task usually takes 40 seconds to complete. Usually, on a don't fix up your mind these metrics. Depending on the complexity of the data and the business logic that needs to be executed to process the data, it may vary. But usually, if the MapReduce job has more than 1 TB of input, then to ensure that there are number of tasks, the number of tasks are smaller, the block size of the input data set should be increased to 512 M or 256 M. I mean, you're getting my point? The block size.
Yes.
So if the block size is less, then what is going to happen, Laden? Then more mappers will come into picture, right?
Yeah, but how do you change? How do you increase the size of a block on 512 or 256 on the fly or
No, no, no,
by
no,
setting
no,
up
no,
the
no,
cluster?
no, 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 no.
Yeah,
Never.
that's
That
what
we do it at the cluster level only.
yeah, when we set up the cluster, we have to set up based on how big data is going to be. Then we set
Yeah,
up
no, no. There are two
the
things here, Laden. There are two things here. Laden, there are two things here. One, we decide the block size at the cluster level. That is one thing. That will never get changed.
okay.
Okay. But during your MapReduce job execution, you can change it.
Oh, okay, got it.
There are two things here. That is where, see, the block size at the cluster level is fixed. That cannot be changed. Once you fix that one while setting up the cluster, every time you ingest the data, it is going to be sliced into that size and being stored on the cluster.
But those are the HDFS blocks. The data is actually stored.
Absolutely, absolutely, absolutely.
Okay, got it, Rana. Okay.
But when you are about to process the job using Mapreduce Job, you can set the property. That is the developer part. See, what I said is the admin part at the cluster level. And as a developer also, you have the option to keep a property inside your job. What is that property? The block size of an existing file can be modified by configuring dfs.block.size property inside your Mapreduce job. You got the point?
Yes. So you give the command inside the job
Yes,
to
yes, yes.
change the, okay, to
Exactly.
increase the size.
Yeah. Right? So that's how it is going to happen. But this is a reason why, no, depending on because mappers, number of mappers will not be in your hand. That all depends on the number of blocks for that given file. Based on that, the number of mappers are being decided. Clear?
Yes.
So combiner. See, combiner, see this all is API based. It may confuse you more, but that is why I'm not going into the deeper details. Day one. So at the later stage, if you feel that, you require those details, let me know. I will discuss again. So combiner, you are going to say job dot set combiner. Job dot set combiner. Okay. If you don't say that one, then combiner will not be into existence. So word count Mapreduce program. So I'm just giving you some example. I mean word count example. There are given steps also here. You want, you can go through that. That should not be a problem. See here,
Yes, you have to set reducer, yeah.
right?
Yes.
What is a mapper class? What is a reducer class? What is a combiner class? Same like the partitioner class. Everything you are going to set like this.
Okay, so you have to specify everything in the job.
Ah, yes, yes.
Every step.
Yes.
Okay.
That is why I said one thing. Inside a jar file, there could be number of jobs. So you are going to decide when you are running a specific job. In that job, all these details need to be set. What is a mapper for that job? What is a combiner for that job? Partitioner. Of course, shuffle and sort are default provided by the framework, by the cluster. But you want, you can customize that also. You want, you can customize that also. But usually those are being provided by the framework default. We don't implement even as a developer. What usually we implement? Mapper, combiner, partitioner and reducer. Shuffle and sort are default provided by the framework. Okay. And you'll be having the code for your Mapreduce. Yeah, I'll show you the Mapreduce, the complete Mapreduce job, the word count example. See, this is what the mapper. Okay, you see that one here. This is a map function and this is the reduce function and this is the driver code. Here you see here job.setMapper class, combiner class, reducer class, all been set here. You notice that?
Yes. I took a look at that one today on their website, yeah.
So it is a hadoop.apache.org only.
Yeah.
So you want, I can send you this one so that you can refer that.
I saw that. I saw that one today on the website. I was going
Oh,
through.
okay, okay, okay. That's good. That's good. So I've sent it to you. You want, you can use that.
Okay.
So this is a complete program. Don't worry about the code and all that. If you're able to understand, that's well and good. I appreciate. If you don't understand, have a look at that one. Now this I pack into a jar file and run it like how I executed before. The same like I execute inside my cluster. Okay,
Yes.
that's wonderful, Laden. So please go through whatever we discussed so that we are going to see the speculative execution and why a combiner is needed, all that stuff once again, and see the other performance tuning aspects in the next session.
Okay.
Okay.
Okay.